Multiplication with matrices. First, let's take a look at a scalar product. A scalar product is where you take a matrix and you multiply it by a constant or coefficient. A scalar value is multiplied with a matrix by being distributed through the entire matrix. C and then an A indicates the values in matrix A are multiplied with scalar C. So if I write 3A, that indicates the values in matrix A are multiplied with 3. And the example below shows that. I'm going to take and calculate 3A, and I've been given this matrix A. So I multiply 3 with every single element in the matrix. That provided me with this answer of -6, 12, -9, and 21. Scalar products are nice calculations. The ones that are a little more time consuming are where we multiply two matrices together. And it's really important that you pay attention to the order of your matrices. The reason that it's important to pay attention to the order of your matrices is that there's a specific number of rows and columns that have to match up. Let's take a look at what's been written. To multiply matrices together, the number of columns of the first matrix must be equal to the number of rows of the second matrix. And matrix multiplication is not commutative, so matrix A times B is not the same as matrix B times A. When we multiply two matrices together, it's nice to know what size we're supposed to end up with. So a resulting size of multiplying two matrices is found with the following. Let's first take the example. A 3 by 5 matrix multiplied with a 5 by 2 matrix will result in a 3 by 2 matrix. And the reason is that you take the number of rows in the first matrix and the number of columns in the second matrix, and that tells you the size of the resulting matrix. In a general format, if we look at a matrix that is m by n, it needs to be multiplied with a matrix that has the same number of rows as this one did columns, so the n's effectively consolidate, and you're left with a matrix that is m times p, or the number of rows of the first matrix times the number of columns of the second matrix. The process of multiplying is to multiply each row of the first matrix with each column of the second matrix. So for example, if I take column 1 of the first matrix, it needs to be multiplied with the first row of the second matrix. Let me highlight those. The first row needs to be multiplied with the first column. Now down below, I've shown you those details. I'll get to them in a moment. After you multiply the first row with the first column, then you take that same first row and multiply it with the second column. After that, you take the second row, multiply it with the first column, and then take the second row and multiply it with the second column. So let's go through the details that I have down below. I took 4, -1, 3, and multiplied it with 2, 0, and 1. So 4 is multiplied with the 2, -1 is multiplied with 0, and 3 is multiplied with 1. You're going to see that all in one long string there. That gave me the result of 8, 0, and 3, which added to 11. Then I take that first row and multiply it with the second column. So I want to take that same first row and multiply it with the second column. I multiplied 4 times 1, -1 times 1, and 3 times 0 to give me 4 minus 1 plus 0, which is 3. After I multiplied the first row with each column, I took the second row and multiplied it with each column one at a time. And the results were 5 and 2. Multiplication, as you can see, can be tedious and detailed. So what I like to do is I like to use an online tool to carry out all the multiplication. Let's say I have A written in here, so I have 4, -1, 3, 2, 0, and 1. And then I already had matrix B typed in. I can use A times B on technology, and it gives me the answer of 11, 3, 5, and 2. If I wanted details about that matrix multiplication on this particular website, I can select the details button, and it shows me all of the multiplication carried out, so you can verify the method in which I did it was correct.